All right, hi everyone. My name is Stephanie Yen. I am a PM on the Azure deployments team, currently working on Bicep. Alex, do you want to introduce yourself?
Sure. Hey, everybody. I'm also a PM on the same deployments team with Stephanie and also spending most of my time on Bicep.
Sounds good. If you guys have any questions, definitely put them in chat. Alex will be reading that while I present. Before I start, I want to know everyone's experience with ARM templates or Azure. Do you guys know it pretty well or kind of familiar?
You got a thumbs up.
Okay. Cool. So I'm still going to give some background just in case for those.
So Darren's saying you use Terraform.
Terraform. Oh, interesting. Okay, cool. So I'm going to turn off my camera just in case things start to lag. All right, so we'll just get started. So basically this PowerPoint kind of assumes have some knowledge of ARM templates and a basic knowledge of Azure, but if you know Terraform pretty well, then I'll give some extra information on parts of ARM or Azure Resource Manager to give you some of a deeper understanding. So what is Bicep? So fundamentally, if you're using Bicep or ARM templates, it's to consume Azure resources. We have a lot of resources you can create, such as virtual machines, Kubernetes, app services, all under this cloud computing branch. So when you use Azure Resource Manager, you can make a request to Azure to create you a new VM. And it comes in through the ARM API and gets routed to the various resource providers available in Azure. ARM templates are a way to create resources in Azure declaratively, just like Terraform. You can author a template in Json code, which I'll show an example later, and Azure will read what resources you want to create with all of its different specifications and create it with you. So what Bicep is a higher level representation of ARM templates. So ARM templates can be very verbose and takes a lot of effort to just learn the specific language to author a file. We created Bicep to be able to make this experience easier, and I'll go more in depth in the following slides as to why we put so much effort into it. From Bicep, it transpiles into an ARM template code, which creates a deployment resource, and it will go through all of that validation to make sure your deployments are as successful as possible. Why Bicep? There are many ways to deploy resources to Azure. You can use the portal, PowerShell, CLI, Terraform, and just any other options available elsewhere. So why are we creating another way to deploy resources? We see a lot of ARM template usage today with our users, as they are by far the most widely used tool to declaratively deploy resources to Azure. It's a large customer base using ARM templates, despite how difficult it can be to author them, if you guys already know, but it's a very powerful and effective tool. So we wanted to take away a lot of the pain that comes with writing and developing ARM templates and turn it into a simpler authoring experience, hence Bicep. We want the existing experience to be better for current users and make the ramp up for new users a lot easier as well. All right, benefits of Bicep. One of the biggest benefits is simpler syntax. So it's much easier to author and easier to read as well. Here we're looking at Bicep code and ARM template code creating the same resource on Azure Resource Manager. As you can see on the right-hand side, the ARM template has so much noise that it's literally falling off the page, has so many brackets, quotations, parentheses. That's just necessary to be declared in JSON language. We had to work with our ARM template language to be embedded within JSON to make it work. And as you can see, it's hard to fully grasp what's going on in this template through all the noise. JSON's a data structure, not a programming language, which makes it a challenge to author. So we're redesigning the front end of the language to make it easier to work with the existing ARM template language. And with Bicep, we're trying to move it past the JSON and give it its own file to live in, like Terraform. Some other benefits to using Bicep versus other languages outside of Azure, and one of the biggest benefits to using an Azure native language like Bicep is day zero support. So this is a snapshot of all of the services available in Azure, and this list is growing every single day. With other tooling, there's an onboarding process in which they have to create a client to work with new services, resource providers, all of the things that are available in Azure. So we don't have to enable anything first for it to be available to be consumed and deployed with Bicep and ARM templates. So if you're looking to be on the bleeding edge or you're hoping to immediately use a new version of something, an Azure native language is the best way to do so. Cool. Modularity. So this is one of the things that was really challenging to do with ARM templates. There were linked ARM templates to be able to sort of rough patch files together, but we wanted to be able to fundamentally fix that. So what we've done with Bicep is create kind of first-class modularity and first-class code reuse, which is the standard for most programming languages to be able to break down code so other people can use and reuse files. And we wanted to make sure that Bicep supported this. Toolability. This is a really big strength with ARM templates that we have today that our team has put a lot of work into. So what that means is that we do as much as possible to validate as you're authoring within VS Code. And I'll show a little bit later in the demo. We expanded the capabilities from ARM templates into Bicep, like syntax highlighting, better IntelliSense, and it makes the experience so much better. We found that tooling is one of the most basic and fundamental things to the design of the language and compiler. It has to be designed to work and fail well for the user. So everything we're building into Bicep is with tooling in mind to have it work with the language server. Because of this, Bicep has really rich IntelliSense and validation today, which we are working on continuously, making it better and more accurate with each version release. Our tooling is built much more like a programming language and will feel similar to authoring C# files. We've gotten a lot of insight from the people who have created other programming languages within Microsoft too. No state management. So if you're familiar with Terraform, you know that Terraform is reliant on state management as a snapshot of what would be seen in Azure. In ARM templates and Bicep, we're able to leverage Azure as the state itself. So you can perform a deployment on any device and can always pull the state to run any tool with it. So state management is a really huge thing as why some people can prefer a Azure native language versus something external. Goals. I've been touching on these goals for the past few slides, but I want to reiterate the goals as well as the non-goals decided when Bicep was first being developed. We want to reduce the current pain of authoring ARM templates, which we've been able to achieve so far, and we wanted to lower the barrier to entry as much as possible. We want to be a transparent abstraction, which Day Zero support achieves, and we wanted modularity, which I referred to a couple slides ago. For the non-goals, these are just as important as the goals, if not more. So we have no intention on having Bicep be the only language out there for cloud users or Azure users. Whatever way you are interacting with Azure and helping other people interact with Azure, as long as you're happy and successful in what you're trying to achieve, we want that for you. So if you love Terraform, please keep using it. But ARM templates are able to help users out in achieving their goals in Azure, and Bicep is just an improved way to do so. We're not trying to be a general purpose language. There may still be data processing tasks outside of the template you'll need to do with your own scripting and pipeline, but you can pass those outputs into Bicep or pass outputs from Bicep into those tasks as well. But basically, there's no goal for Bicep, there's no goal for Bicep to fill all of these gaps and steps that might be taken and create a general purpose language. So where we are now, fall of last year, was version 0.1 and 0.2. This was just our experimental version, trying to figure out how Bicep works and how we could make it improved from the ARM templates. This past March was our production-ready version. It has all ARM template parity, and this was a huge milestone for us. And today, version 0.4 was our first post-production release, has an emphasis on quality and stability. We continue speeding up the inner loop, and recently, 2 weeks ago, we released our private module registry. So that's pretty cool. Look forward to the public module registry. All right, so before I go into the demo, does anyone have any other questions? Cool. Let me share my screen. All right, so let me see if you can see my window.
Yeah, can see that.
Cool, thank you. So I'm in VS Code right now, as you can see, and we have the Bicep extension here, which you could just find an extension, search up Bicep. And our most recent release was 0.4.1008 with the private module registry. So if you download this, you'll get updates automatically within VS Code. They'll be able to manage everything for you. Basically, what this extension does is it understands the language you type out, like for the C# extension, reads your Bicep language and knows to run our language service, which provides all the great tooling we have for you. It's a .bicep file extension, so VS Code will automatically read that at the bottom here. Cool. We'll get started authoring a resource here. If you're familiar with Terraform, both start off with a resource keyword, and then you can give it what we call a symbolic name, which is basically just a variable reference. You can put whatever you want here. I'll use app plan so I know what I'm creating. And IntelliSense pops up to ask me what type of resource I want to create. Each option here tells us exactly what resource type we want with the API version listed as well. I'll start typing server farm. This is what an app service plan is called at the API level. So when authoring a Bicep file or ARM template, you'll need to know the specific names of each resource you're hoping to deploy, which can be a bit of a learning step, but these are important to understand each type and what they deploy. If you're using Terraform or PowerShell or anything else, it might say app service plan in that context, but usually it will show up with the name server farm. So learning Azure Resource Manager at its lowest level is extremely valuable when authoring these templates, since it gives you the context of what's happening underneath the file itself. I'll pick the server farm and choose the most recent API version here. And right away, I'm told that this resource is missing information. I'll need to include the location and name properties. So I'll give this website name. I'll call it Steph, and I'll give it the location, resource group dot location, which is my resource group's location. So if you're not familiar with resource groups, in any Azure subscription, you can have a number of resource groups. Each resource group has a location which corresponds with one of the data centers in Azure. I'm setting the location to be the same location as where the resource group is located. So I need to define a few more properties. So here I typed control space to get this dropdown of other available properties. This menu is generated from what the resource provider gives us. In this case, it's Microsoft.web. As you can see here, they define the APIs in Swagger, and we consume that to generate this information off of what they define. This pretty much shows that we're a thin abstraction. We're not creating this list of properties. This is what we get from the resource provider directly. So for the kind, I'll choose to create a Linux app service plan. And for the SKU, this has to be an object, and I just want a name. So I'll choose B1. This, like before, is knowledge you'll need to know about ARM before writing the template. B1 is one of the basic tiers. So most resources have different SKUs that generate different levels of performance. So you can update this for stronger performance if you want. And I'll just choose B1. So we'll also add properties, which is another object, and oops. I'll have to put in reserved true so that that plan can run on Linux. So I'm also going to create a parameter because I don't want a static resource name. So param is the keyword we want to use, and I'll use the symbolic name prefix, which will be a string type. I want to edit the resource name here to use string interpolation. So this is how you do it. And simple as that. I also could choose for the SKU to be parameterized as well. Give it a string and give it the default value of B1. And I can replace this hard-coded SKU with the parameterized SKU. So you can easily change that up here. And the last thing we're authoring in this app plan is an output. When I consume this Bicep file, I want to give some information for it to be able to work with the app service plan in another Bicep file or in a script or a pipeline. This output allows others to work with the file to consume it as well. So we'll call it plan ID, which is a string, and reference the app plan here. And this just pops up with our IntelliSense. So simple as that. Now this is what we call a raw resource declaration. At its lowest level, this is what an API expects when creating a resource. From this step, I could also consume this as a module, and using a module, you don't have to rewrite the code to deploy it again, and could just reference it and populate the parameters as necessary for each deployment. We're currently working on building the module registry, the public module registry, and the private one is already available. So now we're going to switch to our main Bicep file. 1 second. My battery is low. Okay, so this is what we're going to use to consume that module we just wrote. The first thing we do is set the target scope. Be any of the 4 scopes listed here, and in Azure, you can deploy a file to a single resource group, whole subscription, management group, which is a collection of subscriptions or other management groups, or an entire tenant. Our most common cases are resource group or subscription, so I want to set it to a subscription. So the next thing we're going to do is create a resource group, because most resources you create in Azure live in the resource group. We're going to write down resource. I'll call it RG for resource group. And then again, IntelliSense pops up. I'll add resource group. This is the most recent one. So again, this needs a name and location. I don't want to hard code this location either, so I'll have this point to the deployment location. So deployment is another resource that gets created as part of this code, so we can pull the location from that resource. I'm going to name my resource group Steph-Yan-RG for my own reference. And now I want to refer back to the app service plan we just created here in app-plan.bicep. We'll use that keyword module and call it app plan deploy. And I'll get some IntelliSense on what I can consume as a module based on type. So I'll choose here the app plan bicep file that we just used, or that we just created. And here are the properties that we can set. We can choose depends on, we can name it, more parameters, and set the scope. So the module is just a bicep file and can be deployed to any scope in Azure, and we want this deployed at a resource group. So I'll set the scope. Coincidentally, we just created a resource group. So you see that it pops up here as RG, and it knows to deploy this plan to the resource group that we just created. I also want to give it a name. I'll call it app plan deploy. And I want to set some parameters. So again, you'll see that we set these two parameters in the app plan file. Only the name prefix is required because we already set the SKU. So I'll give it the name prefix. And you can override the SKU here, but I think I want to keep it at the same performance. And this is all I need to deploy the app service. So this block of code is integral to modularize the code, an important concept to learn when you want to consume modules for future use. We've tried to make it easy and straightforward to simplify modularization and help you manage them more efficiently. The last thing we want to do is instantiate the website itself. I have another bicep file here, which creates a website. I don't want to go too in depth because it's a pretty standard resource definition for a website, and there's a bunch of parameters that have been set up for me. So it's going to output some information when I deploy. Specifically, this website deploys Docker images as its source for application code, and we're going to reference an image from Docker Hub in our main bicep code. So we'll go back to the main bicep code, and I need to author another module, which I'll call deploy site. I'll reference the site we just looked at. This pops up again, so I'll do site. And you'll see these are the properties that are required. So we need the, sorry, one second. Need some parameters. Based off of what this says here, these are the ones that were shown in site.bicep that were created for us. So we need an app plan ID. And referring to the raw resource above, we created this app plan, and the website will have to sit on top of this app service plan, so we'll have to tie them together. In order to do this, we have to grab the output from the app plan module. So using IntelliSense, we can type app plan deploy here, grab the output, and get the plan ID. Simple as that. Let's see. We also need a name and scope. So again, I'll scope it to the resource group and give it a name. Deploy site. So some other parameters that are required, Docker image, we'll name it engine x demo/hello. Give it a tag, give it latest, and let's see, the name prefix, which I'll put as Steph. I'll also want to set an output, which I want as a site URL, and we'll make it a string. So this will be the deploy site dot outputs. So when this template runs, it will output the URL, and I can go directly to the site itself. Cool. Now this is all we need to create a website using a Docker image, and we can deploy these files from here. However, let's say we want to loop through deploying several websites. What we're going to want to do is create a websites variable. And we could put it above here with the keyword var, websites, and put a bracket. So we could do two websites. The first one I'll name as fancy website, and I'll tag it with latest. And the second one I can do name plain website with the tag plain text. Cool. Now we're going to need to edit the module itself so that it counts for two different websites. So this mainly stays the same, but we have to loop through the websites. So next is site.bicep. we'll have to do for site in websites, and we'll close this bracket here. We can also, again, use string interpolation to add site.name, so we know which site we're deploying. The name prefix as well can be changed to site.name, and the Docker image tag can be site.tag, so we make sure that we're referencing the right stuff. We also have to change this outputs because we have two different URLs. So we'll change the string to array and make this for site, I in websites. We'll do deploy site, so we know which ones we're deploying, and close the bracket. So now we can deploy this. Let me open this terminal. You can either use Azure CLI or Azure PowerShell, whatever you're more used to, but I'll use Azure CLI. So I'll type az deployment sub create, and depending on what you're deploying, it can be az deployment tenant, resource group, or MG, just whatever scope I want to target in Azure, and I chose subscription. So -f.
Hey, Stephanie.
Yeah.
Stephanie, I think you might have a rogue square bracket. If you just scroll down, just at line 36.
Line 36, this is necessary to make it a loop.
Isn't your output 38 sitting outside of it then? That just seems a bit odd.
The output is a separate top-level declaration from the module.
Right.
Yeah. So just like here, the output sits outside of the resource.
Okay. Sorry.
All good. Thanks for pointing that out, though. Allocation East US, because it's pretty close, and -c. So our -c will run our what if, which will predict our deployment for us. So when we run what if, it's going to show us what we're going to do. If there are any errors that are found in my code, they're going to be caught here because we do some further validation. If it looks good, we can just then choose to deploy it then. I think it takes about a minute or two, but does anyone have any other questions?
I'm assuming at this point that when you try and do the run, if there's any Azure policy violation, that would kick back here. Is that right? So if you for the scope of like you as a user, Stephanie, I'm assuming that if there are certain policies in place that meant that you can deploy resources or certain types of resources or whatever, that you get some form of error back.
That's right. So particularly for deny policies, what if we'll check against those policies? So if we were not allowed to deploy to East US in this case, that you would get an error at this point saying you're violating this policy, so on and so forth.
Got you.
For audit, we won't show you the results here. That is something that we want to add. So if you would be violating a policy that does not block deployment, you won't see that here. And then the other effect that we do work with is modify, which is a newer effect where we'll actually change your request. So if you think about like adding tags or changing the value of something, which you can now specify in certain cases with policy, that will also get reflected in what if. So it's pretty useful in that sense as well.
Got you. Lee, you've got your hand up. I think you got a question.
Yes, quick one. Tools. I mean, I just, the extension, especially the usage at the start, just made me think with VS Code. I used to use Visual Studio like most people, predominantly for everything, but I find myself increasingly using VS Code for work now, largely because of the plugins and things. So two questions: what kind of tool support do we have in Visual Studio, and what is the consensus in terms of using either tool? Is there a preference, or is there a specific benefit using VS Code? Because I find Visual Studio sometimes a bit too heavy, but it also is the proper IDE, whereas VS Code is simply a text editor in a way.
So Today, we only have support in VS Code. The way this works is we implement something called the Language Service Protocol, or LSP. And all that means is it's a generic package that can be invoked from any IDE. We have not prioritized Visual Studio, although we have gotten the ask, and it shouldn't be too terribly difficult to enable it. But today the work has not been done. There have been community projects for enabling support in other editors. So if you're using Sublime, for example, is another popular editor, or NeoVim, people have actually built support for that for Bicep, which has been pretty cool to see the community do that. In terms of the editor that you use, obviously, if you're doing Bicep, then VS Code is going to be your best experience. But it's definitely a personal choice of which editor you want to use. I think the lines are definitely getting blurred of whether VS Code is a text editor or an IDE at this point, because they've been adding so much functionality. But it is definitely more lightweight than Visual Studio.
Thanks for that. I really appreciate that. For me, I think the killer is the debug support. And I know debugging is always a bit complicated with Visual Studio, whereas there's some big advantages with, say, the Kubernetes bridge in VS Code. So, no, thanks for confirming my gut instinct there of the way to go. I appreciate that.
Yeah, of course.
I think that's it for questions for the moment, Stephanie.
Cool, thank you. So here you could see all of the screen, and this is what what if will run. So it tells you what resources are going to be created. If there's anything that is going to be modified or deleted, that will show up here as well. Modified would be yellow, and deleted would be red. So I executed the deployment. I said yes, and this is what is outputted. And that's all for the demo. And let me switch back to the presentation.
So we have got a couple of questions in the chat.
Oh, sure. Okay.
So the first one is from Dave Moss saying, when deploying via Bicep within a release pipeline, is there any way to override the parameters provided in the parameters JSON file? The ARM deployment task has configurable properties for this. However, the docs seem to recommend using just an Azure CLI task to deploy the Bicep.
So when it comes to overriding parameters specified in the JSON, my understanding, and I'm always a little unclear on this because it's different between PowerShell and CLI is my understanding. I believe in CLI, you can override parameters on the command line. So you can say -- parameters and then pick the parameter that you want to overwrite. That may work with PowerShell as well, but I'm not 100% sure on that. When it comes to having dedicated tasks for deploying Bicep, in DevOps pipelines, I don't believe there is a dedicated task for this. We don't own the ARM template deployment task, funny enough. That's owned by another team. But there is one for GitHub Actions. The GitHub Actions one is a pretty thin wrapper over the CLI, is my understanding. So we tend to recommend CLI just because it exposes everything and we don't need to do any further updates or anything like that. Though I suspect as time goes on, we'll have parity with those existing deployment tasks. We have some documentation on using both pipelines and DevOps with Bicep, so I'll show that documentation here as well. And then there's a ton of Microsoft Learn content on using Bicep with pipelines that covers multi-stage releases and all the kind of nitty-gritty stuff that you would expect to do with pipelines. They have that in the context of deploying Bicep code, so it's really helpful.
Cool, thanks, Alex. Actually, that's quite a good segue into Maciek's question, which is, are there extension stroke templates for Bicep in DevOps? And if yes, how do you structure Bicep files in branches? Yeah,
I will defer to the MS Learn content because it's really thorough, and I would botch it if I tried to explain it here.
No worries. That's okay. Stephanie just posted a link as well, so hopefully that can help folks. I think you're going to head back to your slides, Stephanie. Oh, you're back in there, aren't you?
Right, yes. So just moving on from here, just a couple more slides on future releases. So like I said, version 0.5 will have public module registries and pass resource between module. This will hopefully be released in November. Fingers crossed it doesn't get pushed back. And February will be our version 1.0. Our big release will have strict breaking change policy, Bicep Extensibility, which our engineers are working so heavily on, and type updates will separate from core updates. Any questions on releases in the future? Cool. So you can contribute today in VS Code or Azure CLI. And you could also join our Yammer with aka.ms/our-meet. And one more thing, you can also, if you want to join our Bicep community calls, you could type aka.ms/our-news in your browser, and you could sign up for newsletters, invites to the community call there, if you guys want to learn more. And that's all. Thank you. Any more questions?
That's great. Thank you. Any more? Or have we got a shy bunch tonight?
All good.
The only one I did want to add just a little bit of context on the extensibility piece. So today, Bicep exclusively deploys ARM resources, but we do have some interest in completing a broader set of kind of end-to-end deployments to Azure. So things like creating service principals or doing deployments to what we sometimes call data planes, like deploying to a Kubernetes cluster. We are working on some things that you can do those types of scenarios all within Bicep, all with the kind of type safety and validation and IntelliSense that Stephanie walked through for things like service principals and Kubernetes types. So we're just in the kind of early phases of implementation there, but it's pretty promising from what we've seen so far. The Bicep language is built in a way that lends itself to these other scenarios really well. So we are pretty eager to get that out and see what people do with it.
Dave's got another question. Is there any tooling to convert existing ARM templates to Bicep? Aha.
Stephanie, do you want to take that one?
Yeah, I was just trying to find the link. We have decompile. And so you can decompile ARM templates to Bicep. We have this really cool tool. Do you want to talk more about it? Let me try to find the link on our documentation.
Sure. So it does what Stephanie described. It'll take you from ARM template to Bicep. It is machine generated code, and it is kind of a best efforts thing. It works pretty well. I'd say 95% of cases it gets you working code. There are rare cases where if you're doing something strange in your ARM template or something we don't see often, the decompiler may not nail that perfectly, but usually it's a small change that you need to make after the fact. And then in terms of like the names that we generate, those will look computer generated because they are. So you can use some of the refactoring features that we have in the language service. So you can do like rename symbol to rename a resource or a variable and all the references to that resource or variable. So refactoring like you've done potentially in other programming languages. And then I'll share one more doc which kind of walks through the conversion process in more depth, not just literally converting ARM template to Bicep, which is certainly one part of the process, but kind of the philosophy of how you should go about if you need to export existing ARM resources or anything like that, how do you make sure you're doing that in a safe way? And so it outlines all the different steps that you need to do there, and it's pretty thorough. So I'll share that here as well.